So we find mean or median first? Median, yes, thank you. And median, we're looking for what? Equal areas for median. And then for the mean, we have to, because that's the balance point one. For the mean, we have to look for, or think about what we know. If they're roughly symmetric, then the mean's going to be close to the median. If they're skewed, remember the mean is going to be drawn towards that skew. So this, which one was it? Where was Ryan's?
The middle left.
Here. Which that one was a little bit wonky and challenging because that higher bar on the right kind of counters the skew to the left, but I'm good with what he did there. Okay? All right, onward. Let's take a peek. Where are we? Where are we going next? We are all over the place in the packet a little bit. Yeah, we do have to talk about IQR rule, but before we do that, let's look at these 5-number summaries to decide on shape. So that's where we are. The page looks like this, but we're going to look at the bottom part. So we talked about this already a little bit. I've mentioned this to you, but I kind of want to show you some examples with this, right? So if you notice, we are given 3 different 5-number summaries, right? And we need to be able to just look at those 5-number summaries and determine what the shape of the data set would be, what the shape of the box plot or histogram, whatever you would draw, would look like. So visually, remember when we talked about this, I pointed out to you that visually, if we are looking at a box plot, what we want to compare is the distance from our median out in each direction to our quartiles. But then we also want to compare the distance out from median out to our max values, our extreme values as well. So we want to make some comparisons about those particular values and then talk about where the skew would be. So tell me first, if we're looking at, just look at that orange graph, the orange box plot, that box and whisker plot, what would we say about the shape of this box and whisker plot? Is it symmetric or skewed?
Skewed.
It's skewed, and it's skewed to the which direction?
Right.
Okay, this is skewed right.
Oh yeah.
Okay, so think about what that means in terms of what I was just telling you. If we're comparing the distances or the differences between median and our quartiles and median and our maximum values. So what that means you would do is truly just look at those values if you're given the numbers. So it means we would need to figure out what's the difference between our median and quartile 3, and that's 15. Difference between median and quartile 1, that's 15. Those numbers are pretty darn close, right?
About the same.
We also want to look at the difference between median and our max. And in this case, that difference is 25. And we want to compare the difference between our median and our min, and that's 30. So that's fairly close, but it is a little bit bigger on that other side. So what do you think? What should we say about the shape of this graph based on these differences?
Pretty equal.
They're pretty equal, so what would that mean we would say about the shape of the graph? So yeah, roughly symmetric, I would say. Right, we're a little bit different on the right, on the lower end, so it's a little bit longer, but I'd say still we're roughly symmetric on that one. All right, let's take a look at another one here. Let's find our differences. So we're looking at this difference and this difference. So 50 to 58 is 8, 50 to 25 is 25. We also need to consider this difference and this difference. So 50 to 63, that gives us 13. 50 minus 15, that gives us 35. So much bigger differences on this lower end, on the lower numbers. So what does that mean in terms of the shape for the graph?
Skew left.
Skewed left. There you go. By the way, what percent of data values are between quartile 1 and the median?
25.
25%. What percent of values are between the median and the maximum? 50%, right? Okay, so remember we're breaking this into quarters or quartiles. Okay, what do you think this one's probably gonna be?
Skew right.
Probably skewed right, but let's check and see. So I'm putting a question mark there for now, let's see. Okay, difference between median and quartile 3 is 18. Difference there is just 2. Difference here is 10. Difference here is 30. So yeah, these values here are definitely higher. So I would say, yep, we are definitely skewed right here, aren't we? Let me erase that. Put an exclamation point. Yes.
2 exclamation points.
2.
No, that's true.
Definitely skewed right.
6.
All right. Does that hopefully kind of make sense to you guys? Sure, Mrs. Ireland, clear as mud. Okay. All right, onward. You guys have information in here already written in. There's one more value I actually want to add, one more data set I want to add and ask you to find the 5-number summary for. So let me get that written in. I realized my lists yesterday all kind of had one particular trait in common, so I want to give you another list. So 4, 16, 18. I will move this again so you can see it a little bit clearer in just a second. All of the numbers. Okay. Get that list written down and then do me a favor and find your IQR. Well, find your 5-number summary and your IQR, I guess I should say. Okay, so what do we get for our 5-number summary on this? Our min is 4, quartile 1 is 18, good. Median is 22.5. Keep going, Chris. Quartile 3 is 30, and our max is 50. So our IQR is 12. Okay.
When you take the Q1 without counting the 2 numbers used for median.
Correct. So that was what I realized I had not done yesterday, was showing you any examples. There are 2 middle numbers here to find your median. So you are not going to use either of those numbers when you are finding your Q1 or your Q3. So that's what's a little bit different of how we are finding our 5-number summary compared to what calculator will do. So please be conscious of that. Okay, so here's the deal. We are going to use now one of the main reasons, besides just helping us get an idea or a span, right? IQR tells us what the difference is or the span is for the middle 50% of our data, right? From quartile 1 to quartile 3 is the middle 50% of our data.
Yes.
So we can use the IQR, besides giving us that information, we can use the IQR in order to help us determine. There is a rule or a guideline that has been created to help us decide if there are outliers. So the IQR rule is to help us determine if there are outliers. And what the rule tells us, some math books actually literally, they don't just call it the IQR rule, they call it the 1.5 IQR rule or the 1.5 rule, okay? So what we are going to do is we are going to multiply the IQR times 1.5. So we take what we know our IQR to be. So IQR in the first example was 6. So if we multiply that by 1.5, then we get that this new value that we get is 9, right? So what we do with this new value that we've come up with, that's 1.5 times whatever our IQR is we are going to find what's referred to as our lower fence and our upper fence. In other words, we are going to subtract that amount from our quartile 1. So on that first example, what was quartile 1? 4. So we do 4 minus 9, and we get negative 5. That's what's considered our lower fence. And then we add that value to quartile 3. So in this case, our quartile 3 was 10. If we add that to quartile 3, then we get what's referred to as our upper fence. So we find our upper and our lower fence to basically give us a barrier to say we cannot have any numbers beyond these values. And if they are beyond those values, then we can state that they are outliers. So based on the IQR rule or the outlier rule, do we have any outliers for this set of data? No, none of them. None of them are lower than negative 5, right? Typically, if you're going to get a negative value, it's not going to even be anything you have to consider. But we do need to look at that upper fence. So the upper fence is 19. We don't have any values that are greater than 19. So we don't have any outliers in this set of data. All right, we're pushing it on time. So I want to jump down to one where you do see, I'm sorry?
What number?
Let's look at this next set. Okay, our IQR, so you take your IQR, remember you're going to multiply it times 1.5. So in that case, what do we get? We get 43.5. So we're going to take quartile 1, and we're going to subtract that value. So what was our quartile 1? 129. So 129 minus 43.5. So 85.5. That's our lower fence. And then we take quartile 3 and we add this value to it. So 158 plus 43.5, and we get 201.5, and that's our upper fence. And so what do we find here? Those are our limits. We can't go any lower than 85.5. We can't go any higher than 201.5. Do we have an outlier?
Yeah, 64.
Yes, we do. 64 could be considered an outlier based on this rule. Okay. All right. Okay, couple things. Actually, 2 things I need to talk to you about. Number 1, your homework is a flip grid, and I will show you those directions here in just a second on what you are going to do. And then make sure you go back and do some review, look through this note packet. It seems like we've bounced around a whole lot, but anything that we have done in here so far is going to be fair game on your quiz.
Even the stuff from the first quiz?
No, this is on this packet. I'm sorry, let me be more specific. On this particular packet. Okay?
When are we getting our test back?
I was hoping to give them back today, but then I realized time-wise that's probably not going to happen, so I'll get them back to you probably when you're taking your other one. Quiz. This is a quiz. Okay, so you're going to do a flip grid for me. Notice what you are going to do. Look at those directions. Create 2 data sets that include at least 15 data values each. Make them up yourself. If you feel like you need to go and look at some other resources, you can do that, but you need to write these out by hand yourself, okay? One of your sets should be skewed, the other set should be symmetric. Doesn't matter if it's skewed left, skewed right, you choose. Draw a plot of your choice to display each data set. So you could draw a histogram, you could draw a box and whisker plot, stem plot, you choose. And then explain which set of data requires the use of the mean and standard deviation, which requires use of the median and 5-number summary in order to represent the data most clearly, and why that is the most appropriate way to represent the data. Go back and think about what we've talked about with respect to that. You have that in your notes, so you need to look for that information. You're going to draw those graphs nicely, neatly. Do not draw haphazardly, quickly drawn sketches. I want to be able to see what your data is. I want to be able to see your sketch of your graphs, and then you're just going to talk me through that, explaining, here's my graph of my data. It's roughly symmetric, or it's skewed to the right, or whatever, And because it's this, we should use mean and standard deviation, or a median and 5-number summary in order to represent them, because that type of thing. Okay, so that is due by, I think I've got it set to be due by day 1. I need to go back and check, but I'm pretty sure I have it due by day 1, because I want you thinking about that for your quiz. Okay,